What if I told you the closest star to Earth is not in some distant corner of the cosmos, but right here, warming your skin, powering your heartbeat, casting shadows on your sidewalk? We forget because it's always been there, familiar, constant. But that fiery sphere in the sky is no different than the stars we chase in the night, just unimaginably close, burning with the same fusion, governed by the same laws, whispering the same ancient truths. We don't see the miracle anymore. We've grown blind to the brilliance. But not today. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. It starts with light blazing through the edge of the world, cutting across the cold vacuum like a scream of creation. The Sunday, our Sunday, the only star we've ever touched, the only one whose name we say without reverence, because it feels more like a parent than a mystery. But that is a mistake. The sun is no lamp. It is no background. It is a wild, nuclear animal. From Earth, the sun feels eternal. It rises, it sets, it shines. But what we call every day is anything but ordinary. The sun is a living furnace, a ceaseless engine of nuclear fusion converting hydrogen into helium, mass into energy, time into warmth. Every second, it transforms 600 million tons of matter. Every second. That's not fire, that's alchemy. And yet, for all its rage, the sun is gentle because it is near. The only reason it glows brighter than all other stars is not because it is special, it is because it is close. So close, in fact, that it has become invisible to our curiosity. You could say the sun suffers the fate of all things taken for granted. But let's fix that. The distance between Earth and the sun is 149.6 million kilometers. So far, you drive for 170 years at 100 kilometers per hour just to reach it. Fly on a commercial jet at 900 kilometers per hour, 19 years, non-stop, and that's only one way. Still, in the vastness of cosmic scale, this is nothing. Astronomers needed a new ruler for such small distances, so they created one astronomical unit, AU, the span between Earth and the Sunday. It became the yardstick of the solar system. Mars, 1.5 AU, Jupiter, 5.2 AU, Pluto, distant and icy, 39 AU. But the sun doesn't just define distance, it defines time. Because light isn't instant. It travels at a blistering 299,792 kilometers per second. Yet, even at that speed, sunlight still takes 8 minutes and 20 seconds to reach us. Pause here, look outside. That golden shimmer touching the leaves? That's the past, a gift born 8 minutes ago. If the sun vanished right now, collapsed, exploded, gone, we wouldn't even know. For 8 full minutes, Earth would bask in the illusion of stability. And then, suddenly, night. That's how far 1 AU truly is, not just in kilometers, but in seconds of survival. But the light doesn't come from the surface. It's born deep within, in a realm no eye has seen and no probe has entered. The core. In this infernal chamber, temperatures reach 15 million degrees Celsius. Under such pressure, hydrogen atoms normally repulsive to one another are forced to fuse. It's a cosmic paradox. Unimaginable violence births serene light. From chaos, order. Surrounding the core is the radiative zone, where energy struggles to escape, bouncing endlessly like a prisoner in a crowd. A single photon can take tens of thousands to millions of years to reach the surface. Imagine that. The warmth touching your skin today may have been born when humans first began to speak. Above that lies the convective zone, a boiling ocean of plasma. Hot material rises, cools, sinks, repeats. It churns like a cosmic soup, pulling energy closer to the skin of the star. And then finally light breaks free. What we call the sun is just its visible surface, the photosphere, a turbulent shell 5,500 degrees Celsius hot. But even that is not the end. Above it floats the chromosphere, And beyond that, the mysterious corona, the sun's outer atmosphere. Here's the puzzle. The corona is hotter than the surface, millions of degrees hotter. How? We don't fully know. It's one of many solar riddles. Why do its outer layers burn brighter than its core? What triggers its flares and storms? What invisible threads twist its magnetic fields into violent outbursts? Because make no mistake, the sun has moods. Sometimes it erupts. Flares tear across its surface. Coronal mass ejections fling billions of tons of plasma into space. These solar storms can knock out satellites, black out power grids, and fill our skies with auroras, the northern lights, Earth's silent dialogue with the sun's breath. Beyond visible light, it emits ultraviolet rays, infrared radiation, radio waves, X-rays, a whole invisible spectrum of messages. It even releases a solar wind, a constant stream of charged particles that never stops flowing outward. The sun is not calm. The sun is barely contained. But perhaps the most beautiful truth is this. The sun is not original. Only about 2% of it is made of heavier elements: carbon, oxygen, iron. That tiny sliver of stardust is the inheritance from ancient stars, long dead, which means our sun is not a firstborn. It is a second-generation child of the galaxy, formed from the ashes of explosions past. The iron in your blood, the calcium in your bones, the carbon in your breath, they were forged in the hearts of other stars. The sun merely gave them a second life. We are not just orbiting a star, we are orbiting memory, fire shaped by forgetting. In the taxonomy of stars, the sun is a G-type main sequence star, a yellow dwarf, not too hot, not too cold, not the brightest, nor the dimmest, just stable. And in that stability, it gave Earth the one thing rarer than gold: time. It's been burning for 4.6 billion years, and will likely continue for 5 billion more. In a universe of supernovae and black holes, that kind of steadiness is a miracle. It gave life the chance to crawl from oceans, build pyramids, write poetry, and now, look back at its source. When it dies, it will not explode in glory, to number. It will swell into a red giant, swallow Mercury, perhaps Venus, maybe Earth. Then it will shed its outer layers and collapse into a white dwarf, a glowing ember cooling through eternity. But that's not for a long time. For now, the sun shines. It anchors. It defines. It burns in silence, not because it is peaceful, but because it is loyal. It is our cosmic constant, and we forgot, somehow, that it's not unique, it's one of billions, a single bead in the cosmic rosary. And yet, to us, it is everything. And so, we look up at the sky, not to escape the Earth, but to understand why the Earth is possible at all. We begin here not because the sun is exotic, but because it is home. Beneath the surface of our closest star lies a secret world, one we will never see, never touch, and never escape. The sun does not just shine, it lives. It pulses. It roars in silence across space. And at its center, hidden by light and time, a heart beats, not like ours, not with blood or rhythm, but with fusion, with pressure, with endless, impossible fire. This is no gentle fire, no warming hearth. This is the kind of fire that creates reality, the kind that can only exist where atoms surrender themselves to each other and become something new. It is the most violent piece in the universe. At the center of it all, the core, imagine pressure so immense that matter forgets how to be solid, liquid, or gas. Here, everything is plasma, a soup of charged particles so hot that electrons are ripped away from atoms. 15 million degrees Celsius. That's the temperature in the core. The numbers stop feeling real. But what happens here is very real. Hydrogen atoms collide and fuse into helium. This process, nuclear fusion, is the engine of the cosmos. It's what powers every star you've ever seen. But it's also inefficient and brutal. Most of the mass isn't even turned into helium. A tiny fraction, just 0.7%, disappears entirely, transformed into energy by Einstein's famous equation, E equals mc squared. That's the miracle. A little bit of mass becomes light, heat, radiation. Every second, the The sun loses 4 million tons of itself. It doesn't burn, it sacrifices. This energy must escape, but it doesn't race out like a bullet. It must crawl through the radiative zone, a thick, dense layer surrounding the core, where photons bounce like prisoners in a crowded room. For them, the path is a labyrinth, a drunken dance of absorption and re-emission, each step taking them further from their origin. And here is where things get poetic again. That light, the light that touches your skin on a summer morning, might have been born 1 million years ago in the core. What you see now is ancient fire. A photon's journey from the core to the surface can outlive species, civilizations, ice ages. In the radiative zone, the light is delayed not by space, but by interaction. It keeps trying to move forward and keeps getting stopped, like truth in a noisy world. But above that, something changes. Here lies the convective zone, a dynamic, turbulent layer where the rules shift. It's no longer slow diffusion, it's motion. Like boiling water, heat rises and falls in vast, roiling currents. Huge loops of plasma churn and tumble, ferrying energy from the depths toward the surface. This is where the sun becomes restless. This is where its moods are born. The motions in the convective zone twist and stretch the sun's magnetic field lines into tension. Sometimes they snap. When they do, the surface erupts flares, sunspots, storms. The convective zone is not merely a transport system, it is a crucible of magnetism and chaos. And the proof is in what we see with our eyes. The photosphere, the layer we call the sun, is just the surface of this boiling cauldron. It is not solid, it is plasma. At around 5,500 degrees Celsius, it is cooler than the layers below, but still hot enough to blind and burn. Through telescopes, we see it as a seething ocean, marked by sunspots, dark patches that are cooler, yes, but also more magnetic. Above the photosphere, the chromosphere glows with a reddish hue, visible only during eclipses or with special filters. And above even that, soaring outward like a ghostly flame, is the corona. Here is the sun's greatest paradox. The corona is hotter than the surface, millions of degrees hotter. How? No one fully understands. It defies logic. Some theories involve magnetic waves, others suggest nanoflares, tiny bursts of energy occurring by the trillions. But whatever the cause, this inversion is a cosmic mystery, still unsolved, still burning above us. And still, the sun gives more than heat and light. It sends invisible gifts. From every layer of its body, the sun emits a spectrum of radiation. Ultraviolet rays tan your skin and can kill your cells. Infrared waves bring warmth. X-rays speak of high-energy events. Radio waves whisper through space. But the most constant companion of all is the solar wind, a stream of charged particles, mostly electrons and protons, flowing outward in every direction. When these particles collide with Earth's magnetic field, they twist into spirals and ignite the sky in color, the aurora borealis. The northern lights are not just pretty, they are a conversation between our planet and its star. Sometimes, though, the sun screams. Solar flares, bursts of X-rays and energy can hurl out coronal mass ejections, CMEs, vast clouds of plasma that rush towards space like tidal waves. If they hit Earth, they can disrupt satellites, interfere with radio communication, and even knock out power grids. One storm in 1859, the Carrington event, sent sparks through telegraph wires, set offices ablaze, and lit up skies as far south as Cuba. We are small. The sun does not care, but caring is not the point. The sun exists, and from that existence, everything flows. And it exists not as a thing, but as a process, a balance between gravity pulling inward and fusion pushing outward. Should that balance tip, the sun would either collapse or explode. Right now, it holds its fuel, mostly hydrogen, 74%, and helium, 24%. The remaining 2%, everything else. Carbon, oxygen, iron may sound like an afterthought, but it's not. That 2% contains the seeds of planets, of chemistry, of life. That tiny fraction tells a story, the The Sun was born not from raw gas, but from stardust and nebula enriched by stars that lived and died before. That's why we know it is not a first-generation star. The Sun is our foster star, shaped by ancestors we will never know. In astronomy, we classify it as a G-type main sequence star, a yellow dwarf, unimpressive on galactic scales. But we've come to understand something vital about such stars. They're not the loudest. They're the longest lasting. Massive stars burn out quickly. Red dwarfs live forever but lack light. The Sun, it's in the sweet spot, big enough to give life a chance, stable enough to let it evolve, and patient enough to wait. Right now, it is middle-aged, about 4.6 billion years old. In another 5 billion, it will change, grow, swallow, die. But it has already done the most profound thing any star can do. It gave birth to life that could look back at it. So when we speak of the Sun, we are not talking about a ball of fire. We're talking about the first heartbeat of our world, the original storyteller, the engine behind every breath you've taken, every seed that's sprouted, every story ever told. The Sun is a teacher, and all other stars are echoes of its lesson. And now that we understand its structure, its sacrifice, and its storms, it's time we met the next star, the one just beyond the reach of our light, the one we call neighbor, even though it hides in shadow. It is strange how closeness doesn't always mean familiarity. Sometimes, the ones nearest to us are the most enigmatic, the ones we've never truly seen, yet never stopped wondering about. So it is with Proxima Centauri, the nearest star to our Sunday, and yet we've never truly met. It hides in the dark, faint and flickering. No matter how clear the night sky, your eyes will never catch it. If the Sun is a spotlight and Sirius a chandelier, Proxima is a coal ember, dim, red, shy, and still, it is our closest stellar neighbor, just 4.24 light-years away, a mere skip across the galactic pond. And yet, with all our technology, all our rockets, we've never even come close. That distance, over 40 trillion kilometers, is both an invitation and a warning, close enough to dream, far enough to despair. Let's pause and truly understand what 4.24 light-years means. 1 light-year equals nearly 9.46 trillion kilometers. Multiply that by 4. And even then, you're only halfway to the next chapter in this cosmic novel. Our fastest spacecraft, Voyager 1, launched in 1977, hasn't made it past a 17th of a light year. At this rate, it would take more than 73,000 years to reach Proxima. That's longer than all of recorded human history. The closest star is a ghost behind time's curtain. Proxima is a red dwarf, the most common type of star in the galaxy and the most elusive. It contains only 12% the mass of the Sun and is barely 1.4 times the size of Jupiter. If the Sun were replaced by Proxima Centauri, Earth would freeze beneath a black sky. Its surface temperature is just 3,000 degrees Celsius, almost half that of our Sunday. It gives off only 0.17% of the Sun's energy. That's less than 1/5 of 1%. A whisper of light in a vacuum of silence. But don't be fooled. Dimness does not mean gentleness. Proxima is not peaceful. It is wild in secret. You see, Proxima Centauri is what astronomers call a flare star. While the Sun has mood swings, Proxima has outbursts. Sudden, unpredictable, violent. Its magnetic fields twist and snap, unleashing flares of radiation far stronger than any storm we've measured on the Sunday. A flicker from Earth's perspective, an apocalypse up close, and orbiting this unpredictable ember is a planet, one that has made the scientific world hold its breath. Proxima b. In 2016, after years of careful data collection, a team of astronomers, led by Guillem Anglada Escude, discovered it not through direct imaging, but through wobbles. They noticed tiny, rhythmic shifts in the star's light. Something was tugging on it, over and over, every 11.2 days. A planet, at least 1.17 times the mass of Earth. This planet orbits extremely close to Proxima, just 7.5 million kilometers away. That's nearly 8 times closer than Mercury is to the Sunday. And yet, because Proxima is so dim, this proximity puts it within the habitable zone, that sweet spot where liquid water could exist. Could, that word haunts astronomy. Could mean oceans, could mean life, could mean hope. But Proxima's flares threaten that hope, because water needs more than distance. It needs protection, an atmosphere to trap warmth and shield against radiation. And radiation is something Proxima has in excess. Flare after flare could strip the air from Proxima B, boil oceans into space, turn any surface into a sterile desert. Unless the planet has a strong magnetic field, one powerful enough to hold the line, a force field against its own parent star. We don't know. We can't see. No landers, no photographs, just numbers, models, equations, dreams. Later discoveries hinted at Proxima C, a larger, more distant planet, likely a mini Neptune. Not habitable, but curious. And perhaps Proxima D, a tiny world hugging the star even tighter. Is it real, or just a blip in the data? Even now, debate continues. So here we are with the closest planetary system to Earth tantalizingly within reach, and yet impossibly beyond our grasp. We long to go, but we are stuck here, waiting for our tools to catch up to our questions. But we are not without imagination. In 2016, the same year Proxima B was confirmed, breakthrough Starshot was announced, a radical vision proposed by billionaire Yuri Milner, backed by Stephen Hawking and even Mark Zuckerberg. The plan? To send a fleet of tiny interstellar probes, each no bigger than a coin, racing toward Proxima Centauri at 20% the speed of light. How? Not rockets, light sails. These ultra-thin mirrors, propelled by high-powered lasers from Earth, would be pushed by photons, no fuel required, just light and will. At those speeds, 60,000 kilometers per second, the probes could reach Proxima in just over 20 years. 20 years, a human lifetime. A dream suddenly feels possible. Each probe, called a star chip, would carry miniaturized cameras, sensors, and communication systems. Once they arrive, they'd snap images of Proxima and its planets, analyze atmospheres, search for signs of habitability or even life, and beam their findings back across the stars. It would be our first direct look at another solar system. Not fiction, not fantasy. Blueprints, funding, physics, hope. Why Proxima? Why not some brighter, friendlier star? Because it's close. And in space, distance is destiny. Proxima Centauri is our cosmic front porch, the first neighbor on the street. It may not be the kindest or most welcoming, but it is there, real, accessible, waiting. And if we can reach Proxima, everything changes. Suddenly, the stars are not symbols, they are destinations. But for now, Proxima remains a stranger. It flickers in our telescopes, it whispers through our data, it reveals just enough to keep us curious and hides enough to keep us humble. It is not a beacon, it is not a promise, it is a test of how far we'll go to chase uncertainty, a test of whether humanity can look beyond comfort and into the shadows, trusting not in answers, but in questions. That's what Proxima gives us. The closest star, the hardest truth, that sometimes the things nearest to us are the ones we understand least, and yet they may define us the most. What if the key to reaching the stars isn't brute force but light? Not fire, not rockets, not fuel, just photons, pure momentum, a whisper riding the void. What if we don't need to launch starships the size of skyscrapers, but instead send star fleas no bigger than your fingernail, surfing beams of light toward the abyss? This is not a metaphor. This is a blueprint. This is breakthrough Starshot, the boldest interstellar vision humanity has ever dared to imagine. Let's be honest, the numbers are devastating. Voyager 1, humanity's most distant traveler, has spent nearly 5 decades clawing its way beyond the solar system, and it still hasn't left our cosmic front yard. At its current speed, it would take over 73,000 years to reach Proxima Centauri. That's longer than every civilization, every empire, every recorded word in human history. And that's just to reach the closest star. The dream of interstellar travel has always lived under a shadow, a whispered truth we dare not say too loudly. It may never be possible, but what if that's not the end of the sentence? What if the problem isn't the distance, but the way we think about motion? In 2016, a convergence of wealth, physics, and imagination lit a fire under that shadow. Yuri Milner, a Russian billionaire with a deep love for the cosmos, teamed up with Stephen Hawking, arguably the most recognized scientific mind of our time. Their idea was as outrageous as it was elegant. Build starships the size of postage stamps. Attach them to light sails the width of dining tables. Use a gigawatt-class laser on Earth to fire an intense beam at the sails. Accelerate these starships to 20% the speed of light. Reach Proxima Centauri in 20 years. No fuel, no rockets, just light. Call it absurd, call it sci-fi. But every element of this plan is rooted in known physics. Here's how it works. A starship is a microprobe weighing only a few grams. It carries miniaturized instruments, cameras, sensors, spectrometers, communication arrays. Think of it as a smartphone in space, but even smaller. Attached to this chip is a light sail, a thin, ultra-reflective sheet roughly 4 meters wide, made from materials like graphene or mylar. This sail is what catches the laser's momentum. When photons strike it, they push. Not much, but when the chip is feather-light and the beam is powerful, the push becomes thunder. With enough energy, that push could drive the craft to 60,000 kilometers per second, a fifth of light speed. That's fast enough to cross the distance to Proxima in just over 2 decades. Let that settle in. The first interstellar visitor from Earth, if breakthrough Starshot succeeds, will not be a grand vessel with a crew. It will be a grain of curiosity, a mote of metal no larger than a coin, flung into the darkness like a seed. But what a seed it would be. Imagine this. In the year 2045, a signal returns to Earth. It's weak, encoded, distant but unmistakable. Data, images, from the Proxima Centauri system, from Proxima B, A Hazaretske, a dim sun low on the horizon, maybe clouds, maybe ice, maybe something moving. Even without life, even without oceans or atmospheres, the first close-up glimpse of another planet orbiting another star would be a cosmic revolution. It would be the first time in human history we looked at another solar system, not through imagination, but through a lens. But breakthrough Starshot isn't just about exploration. It's about hope in a timeline we can touch. For centuries, interstellar travel has always belonged to the future, some vague, unreachable era. But this project says, number now, within a single lifetime, within a decade of conception, and it reframes the question entirely. Instead of asking, how do we build a ship that can carry people to the stars? We ask, how do we send consciousness without the body? How do we observe without arrival? How small can wonder become before it breaks the barriers of space? Of course, the hurdles are enormous. We don't yet have a laser system powerful enough to drive these sails. We haven't perfected materials that can survive the intense acceleration. And even if we do, how do we aim a microchip at a target 40 trillion kilometers away and ensure it doesn't miss by a margin of billions of kilometers? Communication is another monster. A signal from Proxima would take over 4 years to return and would arrive faint, distorted, and tiny, requiring antennas sensitive enough to catch a whisper across a void. And then there's the unknown. Interstellar space is not empty. Particle, dust, micrometeoroids. At 20% the speed of light, even a grain of sand could obliterate a star chip. This is not just a technical challenge. It is a philosophical one. Are we ready to send something, knowing it may never survive, never return, never be seen again? Are we willing to fail spectacularly for the slim chance that something glorious might happen? Breakthrough Starshot is not a mission. It's a statement that humanity refuses to be confined by gravity. That wonder still drives us more than profit. That light pure, ancient light can become our new form of propulsion, both literally and metaphorically. If we succeed, we redefine what it means to explore. If we fail, we still leave behind the blueprint for the next dreamer. That's the beauty of the cosmos. It doesn't require us to be ready, only brave. And here's the quiet truth hiding beneath all this ambition. Breakthrough Starshot is not about Proxima. Not really. It's about practice, about beginning. If we can reach one star, we can reach 2, and then 10, and then hundreds. Each visit a conversation, each signal a spark, each journey a reminder that distance is only a question of time. As we drift onward away from Proxima and its flare-ridden planets, we carry this vision with us, not as a passenger, but as propulsion. Because now we know we don't need to wait for warp drives. We don't need to become gods. All we need is light and the will to ride it. What if the next Earth is already out there, waiting not in another galaxy, but right next door? What if the most Earth-like system in the cosmos isn't buried in the spiral arms of the Milky Way, but shines just beyond our reach as a single point of light that's actually 2 suns dancing? Alpha Centauri. You've seen it. Maybe you didn't know, but if you've ever gazed into the southern sky on a clear night, you've likely stared at a mystery. 2 golden suns orbiting one another, masquerading as one. A cosmic duet. A binary flame flickering with the question, could life exist here too? Alpha Centauri is not one star. It is 3. There's Alpha Centauri A, Alpha Centauri B, and their distant, fiery sibling Proxima Centauri, orbiting farther out on the edge of the system. Together, they form the closest triple star system to Earth, and unlike Proxima, dim, turbulent, and hidden Alpha Centauri A and B are visible, bright, stable, familiar. From Earth, your eyes can't tell them apart. They look like a single star, the 3rd brightest in the night sky, but through a telescope, the illusion shatters. You see 2 lights locked in slow gravitational embrace, spinning around each other every 79.91 years, their orbits tracing a celestial ellipse. At their closest, they're 11 times the Earth-Sunday distance. At their farthest, 35 times. That space between them means something profound. Each star could have planets of its own. Let's meet them. Alpha Centauri A is the elder sibling, about 10% more massive than the Sun, 50% more luminous, and slightly hotter at 5,800 degrees Celsius. It's a G2-type star, just like our Sunday, a golden flame, steady and dependable. If Alpha Centauri A replaced our Sun, Earth would still orbit comfortably in the habitable zone. Daylight would feel familiar. Shadows would fall the same. Photosynthesis would flourish. You could stand on a planet beneath this star and almost believe you never left Earth. Alpha Centauri B is a bit smaller, 90% the Sun's mass, half its brightness, and cooler at 5,300 degrees Celsius. It glows orange rather than yellow. A K1-type star, an orange dwarf, quieter and longer-lived. Together, they form a system of contrasts, yellow and orange, bright and soft, massive and modest. But their bond is stable, long-lasting, predictable. In a galaxy where stars explode, collide, and vanish, Alpha Centauri whispers a different kind of truth. Stability is rare, and in the search for life, it may be everything. So, where are the planets? That question has haunted astronomers for decades. With such ideal stars so close, so sun-like, why haven't we found them? In 2012, a team believed they had detected a planet orbiting Alpha Centauri B, an Earth-sized world, tight to its star, with a 3.2-day year. Too hot for life, but still proof. Only, it wasn't. Later analysis revealed it was likely a false positive, noise in the data. Disappointment followed, but the silence didn't last long. In 2021, using infrared imaging, astronomers found signs of something more distant, a possible giant planet orbiting Alpha Centauri A, about as far out as Neptune is from the Sunday. Not habitable, but tantalizing. If real, it could mean the system does host planets, perhaps even rocky ones, closer in, still hidden. We haven't seen them yet. But absence is not absence of existence. It is a reminder. We are still learning how to see. Alpha Centauri isn't just an object of study. It is an icon. It shows up in fiction, film, and future fantasies. It's the setting of James Cameron's Avatar. It's been imagined as home to alien civilizations in Mass Effect, Sid Meier's Alpha Centauri, and countless sci-fi worlds. Why? Because it's close. Because it's familiar. Because it feels like a second chance. In a universe where most stars are red dwarfs, cold, faint, and volatile, Alpha Centauri A and B feel like a mirror, a twin solar system. If we're going to dream of leaving Earth, this is the first place that feels like home. And if we ever did stand there on a planet orbiting either of these stars, what would we see? You'd look up and see not one sun, but two. From a world orbiting Alpha Centauri A, the second sun, Alpha Centauri B, would hang in the sky like a giant moon, casting golden-orange twilight, even at night. If that planet had moons, they'd glow with dual shadows, painted in color by two parent stars. And somewhere farther out, Proxima Centauri would shimmer dimly in the background. Not just another star, a sibling. The view would be like nothing ever seen from Earth. And yet, it would feel familiar. So why haven't we gone? The answer, again, is distance. Alpha Centauri is just 4.37 light-years away, slightly farther than Proxima, but still 40 trillion kilometers beyond our grasp. Voyager couldn't reach it in 100,000 years. But Breakthrough Starshot, the project we explored before, originally considered Alpha Centauri as the primary target, especially A and B. Why? Because if planets are confirmed, especially rocky, habitable planets, they may become the most important real estate in the galaxy. But here's something deeper. Alpha Centauri represents a question, one we must face before we ever leave Earth. Are we explorers or observers? Do we only gaze at stars from afar? Or do we build the tools, risk the years, and go? Every new discovery in this system sharpens that tension. Every failed detection, every ambiguous signal, every flare and wobble, it all adds to the suspense. We stand on the edge of the cosmic diving board, staring at a destination that feels like home, but remains unseen. But make no mistake, the promise is there. 2 stars, possibly many planets, gravitational harmony, relative quiet, proximity, possibility. Alpha Centauri is not just a star system. It is the symbol of our next step. It is the threshold we long to cross. It is a reminder that in the midst of darkness, there are places that might welcome us. We drift onward now toward the next flame, but we carry this one with us. The twins behind us whisper, not in sound, but in gravity and light. They remind us that the familiar may be far, but never unreachable. 2 suns, 1 chance, and maybe, someday, a new home. It doesn't shine. It doesn't call attention to itself. It won't guide sailors or dazzle poets or be named in myth, but it moves, silently, swiftly, purposefully. While we fixate on brighter stars and louder systems, Barnard's star slips through the cosmos like a secret. It is the quietest rebel in our neighborhood, the fastest known star in our sky, a lonely ember, older than memory, still burning, still going. Located just 5.96 light-years from Earth, Barnard's star is the 4th closest stellar system to our own, after the 3 members of Alpha Centauri. But in many ways, it might as well belong to another age. Because this star is ancient, estimates place its age between 7 to 12 billion years, twice the age of our Sunday. It was shining when the Milky Way was young, when Earth was still molten, when life had yet to imagine itself. And in all that time, it has done only one thing with perfect consistency: move. Discovered in 1916 by American astronomer E. Barnard, this little red star was found not by its brightness, but by its motion. Compared to the distant backdrop of stars, Barnard's star shifts its position in the sky by 10.3 arcseconds per year. That may sound small, but in astronomy, it's blazing. It holds the record for highest known proper motion, the angular speed with which it drifts across the sky. No other star seems so impatient to leave its place. Over a human lifetime, Barnard's star visibly moves in the sky. To track it is to watch the galaxy breathe. And where is it going? Closer. In about 10,000 years, Barnard's star will be the closest star to Earth, closer even than Proxima Centauri is today. But for now, it sits in quiet solitude, a red dwarf, spectral type M4, with only 14% the mass of the Sun and about 20% its diameter. If you could place it beside our Sun, it would look like a glowing marble next to a bonfire. Its surface temperature hovers around 3,100 degrees Celsius low by stellar standards, and its total brightness is just 0.04%. That of the Sunday, it is invisible to the naked eye. If you looked up at a clear night sky, you could stare straight at Barnard's star and see nothing. And yet it's right there, closer than almost any other sun in the galaxy. We live in a cosmos that teaches a brutal lesson. Brightness is not the same as importance. Barnard's star is a living testament to endurance. While massive stars explode in youth and collapse into black holes, red dwarfs like Barnard's star burn slow and steady. They sip their fuel. They don't chase brilliance. They chase time. And that makes them the most common type of star in the universe. Quiet, unseen, but everywhere. In the grand calendar of the cosmos, stars like this will outlive everything else. Billions of years from now, when the last blue giants have long gone supernova, when galaxies are dimming and black holes are yawning open, red dwarfs will still be flickering like coals in the fireplace of time. And Barnard's star isn't just old, it's peaceful. Many red dwarfs like Proxima flare violently. But Barnard's star is relatively calm. It doesn't rage, it whispers. That calmness has made it a favorite target for scientists searching for planets, especially the kind that might harbor life. The search has been long and turbulent. Back in the 1960 seconds, Dutch astronomer Peter van der Kamp believed he'd found a planet orbiting Barnard's star. He saw tiny shifts in its motion wobbles, suggesting a companion. Excitement surged. It would have been the first planet ever discovered outside our solar system. But years later, further analysis revealed the culprit was not a planet. It was the telescope, a mechanical flaw, a cosmic false alarm. The discovery was retracted. Barnard's star returned to being a lonely traveler, and van der Kamp's dream faded into scientific history. But the dream didn't die. In 2018, using instruments like Carmene's and HARP's high-precision spectrographs, designed to listen for the heartbeats of stars, astronomers detected a new wobble. Not noise, not hope, data. The signal revealed a planet, Barnard's star B, a super-Earth, about 3.2 times the mass of our planet, orbiting once every 233 days, roughly 60 million kilometers from its star. Not too close, not too far, and yet likely too cold. Because Barnard's star is so dim, its habitable zone lies much closer in. Barnard's star B sits just outside that Goldilocks region. Temperatures are estimated to hover around -170 degrees Celsius, colder than Pluto, colder than Antarctica, colder than comprehension. But still, we wonder, could it have subsurface oceans, heated by internal pressure or radioactive decay? Could it have geothermal vents, like the ones that may have birthed life on early Earth? Could life, once again, cheat the odds? We don't know, but we are looking, and that looking is enough for now. Despite being one of the nearest exoplanets, no spacecraft is headed to Barnard's star. Not yet. We're not ready. But future generations might send missions. Light sail probes, like those planned for Proxima, could one day be aimed here, and if so, they'll chase a star that is literally running away. Because Barnard's star is moving toward us now, but eventually, like all things in the galaxy, it will continue past. It will visit our corner of space, and then vanish, never to return. That is its poetry, not in brightness, not in planetary potential, but in motion. Barnard's star teaches us that even in the stillness of space, nothing truly stands still. That movement can be silent, that age can be graceful, that the closest things can remain invisible until we decide to look. And when we look, we see more than a red dot on a chart. We see a timeline. We see a star that has outlived galaxies, survived collisions, drifted through dark matter and silence, and still carries the flame. A star that was ancient before we existed and will still be burning when we are gone. So we watch, we wait, and we listen to the sprinting silence of Barnard's star, not for what it says, but for what it reminds us, that even the faintest lights can change everything if they move fast enough and long enough and far enough. Look up, a clear night, no moon, the sky is black velvet pricked with light, stars blink back, ancient and indifferent, and yet Wolf 359 is nowhere among them, even when your eyes have fully adjusted, even when the heavens are still, even when you beg the universe for revelation. This star remains invisible. It is one of our nearest neighbors in the entire galaxy, just 7.8 light-years away. But you will never see it, not without a telescope, not without effort. It is the star you've always missed, the ember in the attic of the cosmos. Wolf 359 is a red dwarf, like so many others in our local star neighborhood. But even by red dwarf standards, it is dim, dimmer than dim, a shadow among shadows. Its total brightness is less than 0.1% of the sun's light, so faint it doesn't even make it into casual star maps. But its story is brighter than any blaze. Discovered in 1919 by German astronomer Max Wolf, Wolf 359 earned its number not from myth or majesty, but from a catalogue. Entry 359 inches, a list of stars with high proper motion. It wasn't named, it was filed. And maybe that's the perfect beginning for this kind of star, one that doesn't shine to be noticed. One that simply exists. Let's zoom in. Wolf 359 has only 9% of the sun's mass and about 16% of its radius. If the sun is a beach ball, Wolf 359 is a golf ball, dense, quiet, and cold by stellar standards. Its surface temperature is just 2,800 degrees Celsius. That's cooler than a candle flame, and it radiates less than 0.001% of the sun's light. If our star is a lighthouse, Wolf 359 is a matchstick lit inside a glacier, and yet it burns, it fuses, it lives. Like Barnard's star, Wolf 359 is a stellar minimalist. It burns slow, steady. It could live for trillions of years, long after all the blue giants have collapsed, long after our own sun is cold and gone. This is the kind of star that survives the death of galaxies. No supernova, no fanfare, just silence, stretching into eternity. It orbits no companion. It flashes no flares, at least, none we've observed with certainty. Unlike its tempestuous cousin, Proxima Centauri, Wolf 359 is remarkably still. There are no known planets, no alien atmospheres, no dimming transits, nothing to draw attention. Astronomers have searched. We've scanned its light for the telltale wobbles of an orbiting world, but so far, nothing. If planets are there, they are small, distant, or simply invisible to us for now. But does absence mean emptiness? Or is it just another lesson in humility? From Earth, Wolf 359 lies in the constellation Leo. It creeps slowly across the sky, its motion measurable only by the most precise of instruments. A subtle drift across the backdrop of infinity. If you stare into its region of space, you'll see nothing, but it's there, watching us as we fail to notice it. In a galaxy where everything is moving, Wolf 359 is patient, and what makes it remarkable isn't what it does, it's what it teaches. Because most of the stars in the Milky Way aren't like our Sunday. They're like Wolf 359, invisible, quiet, lonely. Nearly 3 out of every 4 stars in the galaxy are red dwarfs, tiny engines hidden from human eyes. The night sky is a lie. It shows us only the exceptions, only the loud, the hot, the exploding. It hides the truth, that the universe is a whisper, not a roar. Wolf 359 is the whisper. And yet, this star, nearly forgotten by the naked eye, holds a strange place in our collective imagination because of fiction. In the universe of Star Trek, Wolf 359 is the site of one of the most tragic space battles in the franchise's lore, a brutal defeat at the hands of an alien force known as the Borg. The writers chose it intentionally. Why? Because it was close, yet unknown, obscure but real, a star that could hold secrets because we knew nothing about it. Even in fiction, Wolf 359 became a symbol of mystery, of ambush, of silence hiding catastrophe. In our reality, no cubes wait, no fleets burn, no sentient metal lurks, only a star, a small, cooling star that has seen the galaxy turn 7 billion times, that has circled the galactic core for longer than Earth has existed, and will do so for eons still. If we ever send probes to Wolf 359, it won't be because it offers adventure or promise. It won't be because it shines. It will be because it is close, because it is quiet, because it is there. And in the long road to the stars, sometimes we don't seek fireworks. We seek stepping stones. And maybe that's what Wolf 359 Island, not a destination, a waypoint, a reminder that between the flashiest lights in the universe lie the ones that matter most. So we drift on, past the faint red ember, its light already vanishing behind us, its silence becoming a memory. But something lingers, the idea that the universe is made not of brilliance, but of subtlety, and that one of the closest stars to Earth has been hiding in plain sight this whole time, asking nothing of us except this: will you learn to see what cannot be seen? Not all stars hide. Some command the heavens. Some burn so fiercely, so brilliantly, that even the most casual glance upward cannot miss them. And of all the lights in our sky, one stands above the rest. Sirius, the dog star, the brightest jewel of night. To look at Sirius is to feel the paradox of distance. It is 8.6 light-years away, nearly 82 trillion kilometers, yet it looks closer than the moon. Its glare pierces atmosphere, pollution, even cloud edges. For millennia, it has whispered into human myths as though it were more than a star. Perhaps it island, because Sirius is not one star, it is two. The first, Sirius A, is the one your eyes see twice the sun's mass, 25 times as luminous, with a blistering surface temperature of nearly 10,000 degrees Celsius. It shines bluish-white, young and restless, barely 240 million years old, a child by cosmic standards. Where the sun paces itself, Sirius A is a race car screaming around the track. Its life will be short, a few 100 million years at best, before burning out in brilliance. If our sun is patience, Sirius A is urgency. Imagine standing on a world circling this star. The daylight would not be golden but blue-white, searing the landscape in a cold fire. Even night would not be night. Sirius A would blaze like a second moon, casting hard shadows, painting oceans in silver flame. But Sirius does not shine alone. Orbiting in secret, revealed only by patience and precision, lies Sirius B, a white dwarf, a ghost. Once, it was larger than Sirius A, perhaps 5 times the sun's mass. But massive stars burn fast and die young. Long before humans walked the Earth, Sirius B exhausted its fuel, swelled into a red giant, and then collapsed. Its outer layers drifted into space, its core compressed into an object no larger than Earth, yet as massive as the Sunday. Now, it glows faintly with residual heat, 25,000 degrees Celsius on its surface, but it no longer burns. It is a memory, a scar, a testament that even giants must fall. And its density? Beyond comprehension. A teaspoon of Sirius B's matter would weigh more than an elephant. A sugar cube of its stuff would crush the foundations of cities. Sirius A and Sirius B orbit each other every 50 years, locked in a slow, gravitational embrace, life and death intertwined. The existence of Sirius B was first suspected in the 1,800 seconds, when astronomers noticed Sirius A wobbling slightly, as if tugged by something unseen. In 1862, Alvin Clark peered through the largest refracting telescope of the time and saw it, the first white dwarf ever discovered. Its discovery changed everything. It proved stars do not vanish quietly. They evolve, they transform, they leave behind remnants. Sirius B is not just a star. It is a laboratory of finality. Where Sirius A blazes with urgency, Sirius B whispers the future of our own Sunday. One day, billions of years from now, our star too will collapse into a white dwarf, small, dense, cooling. Sirius is not just beauty, it is prophecy. But Sirius is not only science, it is culture. The ancient Egyptians revered its rising, linking it to the flooding of the Nile, the lifeblood of their civilization. They called it Sopdet, the goddess of fertility and rebirth. Their calendars were built around it, their temples aligned with its light. The Greeks named it Sirios, meaning scorching, believing its rising brought fever and catastrophe. Even today, the phrase, dog days of summer, comes from this belief that Sirius, in conjunction with the sun, unleashed oppressive heat. For the Polynesians, Sirius was a navigator's beacon, guiding journeys across the Pacific. For the Aboriginal Australians, it lived within constellations of ancestral stories. For the Dogon people of Mali, it became the subject of cosmic myths, some claiming knowledge of Sirius B long before telescopes confirmed its existence. Whether myth, coincidence, or mystery, Sirius has always been more than light. It has been a sign. Modern science hasn't lost its fascination. The Hubble Space Telescope has separated Sirius A and B, capturing their binary dance in exquisite detail. Ground-based observatories calibrate instruments against Sirius because it is so bright, so constant. It has become a standard candle, a celestial yardstick. Sirius is not just a star we admire, it is a tool we use. But maybe what makes Sirius most extraordinary is this. It is not rare, it is not unique. It is simply close. The reason it dominates our sky is proximity. If it were farther, it would be another faint glimmer among billions. Its brilliance is an illusion of distance. And yet, how often is that the truth of beauty in life? The things we notice, the things that move us, are often not the most rare, only the nearest. Sirius teaches us that brightness is perspective. So here we are, passing by the most luminous jewel in our local heavens. One star young and defiant, one star old and broken. Together, they form a system of opposites: vitality and memory, blaze and ghost, urgency and aftermath. In their union, we see the story of all stars: birth, life, death, legacy. To stare at Sirius is to see our own future written twice, once in fire, once in ash. As we move away, its glow fades but lingers in the imagination. We leave behind the familiar, the iconic, the myth-soaked star of history. Ahead lies a different kind of flame, quiete, fainter, less dazzling, but perhaps more important, because the cosmos is not built only of spectacle. It is built of patience, of smallness, of shadows that endure. Our next stop is such a star. It does not blaze, it whispers. Its name is Ross 128. Not every star announces itself with brilliance. Some whisper, some stay hidden, some are so faint, so modest, that you could stare straight at them forever and never know they're there. And yet, among these whispers may lie the greatest possibility of all, life. This is Ross 128, a red dwarf star in the constellation Virgo, just 11 light-years away. It doesn't flare violently like Proxima. It doesn't sprint across the sky like Barnard's star. It doesn't dazzle like Sirius. It simply exists, quietly, patiently, and orbiting this quiet star is a world that might resemble our own. Ross 128 is small, only 17% the mass of the Sunday, about 20% its size. If the Sun were a beach ball, Ross 128 would be a golf ball. Its surface temperature, 3,000 degrees, cooler than our star, cooler even than many other red dwarfs. Its brightness, just 0.036% of the Sun's light. If the Sun is a roaring furnace, Ross 128 is a candle burning in deep silence. But sometimes quiet stars hold the greatest potential, because around this faint ember orbits Ross 128b, a rocky planet just 1.8 times the mass of Earth, an exoplanet in the habitable zone. The discovery came in 2017, thanks to precise radial velocity measurements. Astronomers noticed a telltale wobble in Ross 128's light, a rhythmic tug caused by an orbiting companion. Ross 128b circles its star every 9.9 days. A year there lasts less than 2 weeks. But because Ross 128 is so dim, that close orbit actually places the planet in the temperate zone, the region where liquid water could exist. That word again, could. It's the word that keeps astronomy alive. But here's what makes Ross 128 truly special: its personality. Unlike Proxima Centauri, which lashes out with frequent flares capable of stripping atmospheres bare, Ross 128 is unusually calm. Its surface doesn't rage. Its storms are muted. It is by stellar standards polite. That means if Ross 128b has an atmosphere, it has a better chance of keeping it. A chance at weather, oceans, climate stability, a chance at life. This isn't just theory. This is hope, scientifically grounded hope that one of the nearest exoplanets may actually be habitable. Of course, habitable doesn't mean inhabited. We don't know if Ross 128b has water. We don't know if it has air. We don't know if it's a desert, an ice ball, a swamp, or a barren rock. But what we do know is this: it sits in a cosmic sweet spot. It orbits a calm star. It is close enough to dream about, and in a universe where most planets are gas giants, frozen wastelands, or scorched infernos, that combination makes Ross 128b stand out like a lantern in fog. There was a moment, a brief, electrifying moment when Ross 128 became headline news for another reason. In 2017, astronomers at the Arecibo Observatory detected a strange signal while pointing their dish at this star. It was brief. It was structured. It was unexplained. For weeks, speculation swirled. Was it alien? Was Ross 128 broadcasting to the cosmos? The truth turned out to be far more ordinary: interference from a satellite in Earth orbit. But for a moment, we allowed ourselves to imagine, and maybe that's the deeper truth. Ross 128 reminds us how thin the line is between science and wonder, between data and dream. If Ross 128b has life, any life, from microbes to forests to oceans of intelligence, it may already know us. Because in 2008, humans sent a deliberate radio transmission called a message from Earth toward another nearby star, Gliese 581. Similar signals may one day target Ross 128. Perhaps in the far future, the faint red ember of Ross 128 will glow, not only with possibility, but with connection. Even if life never blooms here, Ross 128 still matters, because it reminds us of a truth we often overlook. The universe doesn't need to be loud to be meaningful. Ross 128 will never be sung about in myth. It will never outshine Sirius. It will never anchor constellations. But it may cradle life. It may cradle meaning itself. So picture it: a faint red star, barely glowing, a planet locked close, orbiting every 9.9 days, a sky bathed in twilight, perpetual and soft, maybe seas, maybe continents, maybe silence, maybe voices we cannot yet hear. Ross 128b is a reminder that life does not need spectacle, it only needs time, and stars like Ross 128 have more time than any of us can fathom. As we drift onward, leaving this quiet world behind, the darkness no longer feels like emptiness. It feels like a community, a neighborhood of stars, each small, each faint, each whispering possibility. Ross 128 is one of the quietest neighbors of all, but sometimes the quiet ones hold the loudest secrets. We've been moving star by star, like a traveler hopping from island to island across a dark ocean, but at some point, You stop counting the individual islands. You climb to a higher vantage point and see the archipelago. This is where we are now. The stars we've visited so far: Proxima, Alpha Centauri, Barnard star, Wolf 359, Ross 128. They are not isolated wanderers. They are part of something larger, a neighborhood. Our local star neighborhood spans just 16 light-years in every direction, a bubble in space with the sun at its center. Inside it, there are about 50 star systems containing around 65 stars and brown dwarfs. It doesn't sound like much, does it? A mere handful of fires in an infinite dark. But step back, and the perspective shifts. These are the closest suns in all the universe to us. The first stops on any journey outward, the street we live on in a galactic city of hundreds of billions. What does this street look like? Surprisingly, it's quiet. Most of the stars here are red dwarfs, small, dim, nearly invisible without telescopes. Nearly 3 out of 4 stars in the galaxy fit this description. They're not spectacular. They don't flare like fireworks. They don't blaze like Sirius. They just burn slowly, steadily, for trillions of years. A cosmic paradox. The most common stars are the ones we cannot see. The night sky is lying to us, showing us only the outliers. The truth is hidden in silence. But let's wander through the neighborhood a little. There's Lalande 21185, only 8.3 light-years away in Ursa Major, one of the brightest red dwarfs, though still too faint for the naked eye. It may host 2 super-Earth planets. Imagine them worlds heavier than ours, orbiting a dim ember, bathed in perpetual twilight. There's 61 Cygni, a pair of orange K-type stars, about 11.4 light-years away. Astronomers once called them the flying stars because of how quickly they move across the sky. It was here, in 1838, that scientists first measured the distance to a star using parallax, proving, for the first time, that the stars were not just lights on a dome, but vast suns at unimaginable distances. Humanity's first ruler against infinity. Then there's Epsilon Eridani, just 10.5 light-years away. A young orange star, smaller than the Sun, with at least one known planet, a gas giant, plus a wide dust belt, like our Kuiper belt, circling it. Fiction writers have loved this star. It's been home to Vulcan in Star Trek lore, to alien civilizations in novels, to countless imaginings. Why? Because it feels alive, unsettled, dynamic. And then GJ 1061, a faint red dwarf 12 light-years away, with 3 planets. One of them lies in the habitable zone. We don't know its atmosphere. We don't know its surface. But its existence adds weight to the pattern forming in this neighborhood. Planets are everywhere. Pause here. Reflect. Not long ago, we didn't know if planets were rare or common. In the early 1990 seconds, only a handful had been discovered. Today we know of thousands. And in our tiny 1/6 light-year bubble, we've already found dozens of candidates. Do the math. If so many worlds exist here, in our small cluster, how many scatter across the galaxy? Hundreds of billions of stars, trillions of planets. The odds tilt toward abundance, and abundance tilts toward life. Imagine looking at our neighborhood from 100 light-years away. The stars would form a faint, lumpy ball, nothing impressive, no spiral arms, no glowing nebulae, just dots scattered through 3-dimensional space. But for us, inside it, this bubble is home. It's not silent wilderness. It's a frontier, the edge of the known, a district where our telescopes listen, our imaginations roam, and our dreams place outposts on other suns. If humanity ever begins interstellar travel, slow probes first. Perhaps colonies later. This neighborhood will be our playground, relay stations, refueling posts, science outposts, worlds to study, moons to map, atmospheres to taste, a network of ports in the cosmic dark, and it's small, unthinkably small. This bubble of 16 light-years is 40 light-years wide in diameter. The Milky Way is 100,000 light-years across. Our neighborhood is a front yard, a single breath in a city of stars, and yet it matters, because beginnings always matter. Perhaps the greatest lesson of this neighborhood is humility. We see only what is close, we measure only what is near, and even then, our vision is blurry, incomplete. We know some planets, we suspect more, we miss countless others. The neighborhood is teasing us, whispering, "There is more, always more." It reminds us that discovery isn't about conquering the galaxy in one leap, it's about one step at a time. Proxima, Alpha Centauri, Barnard's star, Wolf 315, Ross 128. Each one a spark, each one a seed. So as we drift outward, surveying this cluster of suns, let us remember, we are not strangers here. We are not lost wanderers. We belong to this street of stars. It is our first neighborhood, our first map of infinity, and like all neighborhoods, it shapes who we are. Ahead lies one more destination, a system that once shook headlines and stirred imagination like few others, a system that promised Earth 2.0, then pulled it away. A reminder that science is not certainty, it is patience. And yet, hope endures. We are heading for Gliese, 581. Every era of exploration has its mirages. Sailors once chased phantom islands. Mapmakers filled oceans with dragons and shores with promises of gold. In the 21st century, our mirage appeared not on Earth, but around a quiet red star, Gliese 581. For a brief electric moment in 2010, astronomers believed we had found it. A second Earth, a rocky planet, nestled neatly in the habitable zone, orbiting a calm star. The headlines screamed. The world dreamed. The universe felt suddenly smaller. And then, the mirage dissolved. Gliese 581 lies in the constellation Libra, about 20 light-years away. By galactic standards, it's practically a neighbor. By human standards, it's impossibly far. But distance never stopped curiosity. The star itself is a red dwarf, only about a third the Sun's mass and radius, glowing faintly at 3,200 degrees Celsius. It is old, stable, yet, if stars were people, Gliese 581 would be the patient elder. Not flashy, not volatile, just enduring. And astronomers love such stars, because quiet suns give their planets time to cool, to stabilize, to perhaps harbor life. And planets, Gliese 581 has, at least 4 confirmed worlds orbit this faint ember. 2 gas giants, one rocky planet too close to its star, scorched beyond hope, another too far out, frozen in silence. But in between, for a time, we believed there was a treasure, a planet labeled Gliese 581 grams. The data suggested it was about 3 Earth masses, orbiting in just the right place for liquid water. Not too hot, not too cold, the so-called Goldilocks zone. One of its discoverers even nicknamed it Zarmina's World, after his wife. Artists painted oceans under a crimson sky. Reporters wrote about alien sunsets. Scientists dared whisper, "This could be it." For a fleeting moment, humanity felt the breath of another Earth on its neck. But science is not built on whispers. It is built on repetition, on scrutiny. Follow-up studies questioned the signal. Was it a planet or noise? Was the wobble in the star's light caused by Zarmina's world, or by stellar activity? Small shifts in the star itself masquerading as a planet. The debate raged for years. Papers argued for its existence. Others dismantled it. As of today, the consensus leans toward skepticism. Gliese 581 grams likely does not exist. Our mirage vanished. The dream faded. The headlines fell silent. But the story didn't end, because the system still holds interest. Gliese 581c, a rocky planet, about 5.5 Earth masses, orbits close enough to be considered potentially habitable, though it's likely too hot. Gliese 581d, farther out, may orbit in a colder zone, but could, under the right atmospheric conditions, harbor liquid water. So while Zarmina's world slipped through our fingers, other possibilities remain. Not as Earth-like, not as thrilling, but still candidates. And sometimes, the quieter candidates are the ones that surprise us. But Gliese 581 became more than a scientific case study. It became a cultural one. In 2008, long before Zarmina's world was announced, humanity aimed a deliberate radio transmission at this star, a project called A Message from Earth. It carried 501 digital messages, short greetings, hopes, and dreams sent by people around the world. It was beamed out through a Ukrainian radio telescope, speeding toward Gliese 581c at the speed of light. The signal will arrive in 2029. If anyone or anything is there to receive it, they will hear us soon. Think about that. Even if Gliese 581 has no habitable worlds, even if it is barren, our voices are already traveling there. Our hopes already circle its faint red glow. We reached before we knew what we were reaching for. And maybe that's what makes Gliese 581 so haunting. It symbolizes the fragility of discovery. Science is not a straight road. It is a winding path filled with wrong turns, false hopes, and course corrections. But each misstep pushes us closer to truth. Gliese 581 grams may not exist, but in chasing it, we sharpened our tools. We learned how fragile signals can be. We learned to doubt, to test, to refine, and in that way, Zarmina's world was never a failure. It was a teacher, but still there's something undeniably human about our reaction. We wanted it so badly. We needed it to be true. Because deep down, we're not just searching for planets. We're searching for mirrors, for signs that we are not alone, not unique, not stranded, that the story of Earth is not a cosmic accident, but part of a larger chorus. Gliese 581 let us taste that chorus, even if it turned out to be an echo. So what remains? A star, a handful of confirmed planets, interesting but imperfect, a lost candidate, a phantom world, and a message, a real, physical signal still racing through the void toward this faint red Sunday. If nothing else, Gliese 581 has become a symbol of longing, longing for another Earth, longing for another voice, longing for the certainty that possibility is not an illusion. As we drift past it, 20 light years from home, we feel both the weight of disappointment and the spark of hope, because the search doesn't end here. It never ends. Even false positives remind us of the truth. The universe is vast, planets are everywhere, and the next Zarmina's world may not vanish. It may be waiting, hidden just beyond the limits of our instruments, whispering in light we have not yet learned to hear. So we leave Gliese 581 behind its controversies, its false dawns, its phantom oceans. We zoom out now, past the bubble of our local neighborhood. The cluster of 50 stars begins to shrink into a single shimmering patch, and we turn toward the vastness beyond. Because everything we've seen so far, all the stars, all the systems, all the possible worlds, lies within just 20 light years of Earth. A grain of sand, a front yard, a whisper in a galaxy 100,000 light years across. The neighborhood ends here, but the galaxy waits. We've drifted more than 20 light years from home. We've walked among faint dwarfs and brilliant giants, touched ghosts of dead suns, and whispered around planets that may or may not exist. And yet, as far as the universe is concerned, we haven't even left the driveway. All of it Proxima, Alpha Centauri, Barnard star, Wolf 359, Sirius, Ross 128, Gliese 581 fits inside a bubble just 40 light-years wide. Now zoom out. The Milky Way stretches 100,000 light-years across, with hundreds of billions of stars. Our epic journey has been a single breath in a city without end. The truth is staggering. We live in a galaxy we have barely begun to know. Look again at the map. Our local neighborhood, that cozy cluster of 50 star systems, disappears into the backdrop. From even 100 light years away, it becomes a smudge of faint light, a dot among countless dots. We feel big because we've traveled far, but far is relative. And in cosmic terms, we are still toddlers, clinging to the front porch. The Milky Way is not just wide, it is alive. It spins, carrying us in a dizzying orbit around its core, once every 225 million years. By the time the Sun completes a single galactic lap, the Earth will have witnessed multiple mass extinctions. Civilizations will have risen and fallen, continents will have shifted, oceans will have drained and filled again, and still, the galaxy will turn, unbothered, eternal. But what lies beyond our neighborhood isn't just more stars. It's more stories, star clusters, where hundreds of suns are born together, blazing in shared youth. Nebulae, where clouds of gas and dust ignite into new stellar generations. Supernova remnants, where dead stars scatter elements into space, seeding the future with the building blocks of life. Black holes, silent engines where light itself disappears. And everywhere, more planets. Planets circling faintest, planets circling blue giants, planets circling pairs, trios, and loners. Planets in habitable zone, planets frozen solid, planets flame, planets like ours, planets unlike anything we can imagine. We used to think Earth was unique. We used to believe the Sun was the center of everything. Then we learned the Sun was just one star among many. Now we know there are more planets than stars. The galaxy is littered with them, trillions, perhaps quadrillions. If life is not common, the silence is deafening. If life is abundant, the chorus has only just begun. Either way, the implications shake the soul. Our journey outward is not just about science. It is about perspective, because when you realize the Milky Way holds more stars than there are grains of sand on Earth's beaches, you cannot help but ask, what does it mean to be human here? What does it mean to be alive in a galaxy this vast, this ancient, this indifferent? The stars are not waiting for us. They are not listening for us. They are not here to answer our questions. And yet, they give us the stage. They give us the canvas. They give us the raw material of meaning. It is we who decide what to make of it. The neighborhood was only the beginning. The faint dwarfs, the quiet suns, the ghost stars, they anchor us. They remind us that the first steps are always small, but small steps do not mean small meaning, because from small steps come great journeys. Someday our descendants may leave this bubble of 20 light years. They may sail past stars we can only name. They may colonize moons, orbit gas giants, or breathe the skies of alien Earths. They may look back at Sol, our sun, and see it not as the only star that mattered, but as the one that gave them the courage to begin. For now, though, we are still here, on a pale blue dot, orbiting a modest yellow star, inside a bubble of space so tiny the galaxy would laugh if it could. And yet, this is enough, because beginnings always are. So let's remember the journey. The Sun, our first star, radiant and familiar. Proxima, dim and violent, cradling a dangerous world. Alpha Centauri, the twin suns, a mirror of possibility. Barnard's star, the ancient sprinter, racing toward us. Wolf 359, the invisible whisper, unseen but enduring. Sirius, bright and mythic, fire and ghost in tandem. Ross 128, the quiet hope, with a planet that tempts the imagination. Gliese 581, the mirage, teaching us humility and patience. Together, they form the map of our beginnings. And as we zoom out now, past the bubble, past the spiral arms, past the glowing center of the Milky Way, something shifts. We realize the neighborhood was never small. It was never insignificant. Because to begin is the greatest act of all. Every journey into the infinite starts with a single step. Every exploration of the unknown begins with the known. Every cosmic odyssey begins at home. The stars are not just lights. They are destinations. They are teachers. They are reminders that the universe is not empty. It is alive with possibility. We are small, but we are not insignificant. We are explorers. And the neighborhood is only the beginning.